Hey there, how's it going everybody? In this video, we'll be learning how to work with numeric data in Python. And numbers are most commonly represented with integers and floats. And the difference between an integer and a float is that an integer is a whole number and a float is a decimal. So to see an example of this, let's create a variable called num, and let's just set this equal to 3. Now, Python has a built-in function called type where we can see the data type of an object. So if we print out the type of num and run this, then we can see that it returns that that is of the class integer. Now, if we were to set this number instead to 3.14 and now rerun this, then we can see that now the type of number is a float. So that's the main difference between an integer and a float. Now, when working with numeric data, it's common that you'll need to use some basic arithmetic. So let me grab some comments from my snippets here, just so that we have a reference for everything that we can do. So I'll copy these arithmetic operators and paste these in. And now let's go ahead and just run through each of these. So the first four we've likely already seen a lot and are familiar with. So for example, addition, if we print it out 3 plus 2, then we can expect that that's equal to 5. If we print out 3 minus 2, that should be 1. 3 times 2 should be equal to 6. And 3 divided by 2 should be equal to 1.5. Now, for division to behave this way, this is actually new in Python 3. If you're running Python 2, then this will actually equal 1 because it drops the decimal. But in Python 3, that gives us the right answer of 1.5. Now, if we don't want to drop that decimal, then we do have a floor division, and floor division can be performed by adding 2 division signs. So if I run this, then now we can see it drops that decimal and it's equal to 1. So if you ever see these 2 division signs, then that is this floor division. Now, if you wanted to work with exponents and powers, then we can use these 2 multiplication signs. So if we wanted to print 3 to the second power, then we could just say 3 with these 2 multiplication signs. And if I print that, then we can see that that equals 9 because 3 squared is equal to 9. Now, this last operator here is called a modulo operator, and it gives us the remainder after a division. So 3 mod 2 will have a remainder of 1 because 2 goes into 3 once with 1 left over. So if we say 3 mod 2 and run that, then we can see that that is equal to 1. Now, a common use case for this is to tell if a number is even or odd. Now, the reason for this is because every time you divide a number by 2, there are only 2 possible remainders. It's either going to be 0 or 1. So, for example, if we look at a few more examples here, so let me just print out a few more modulo operators, and I'll do 2 mod 2, 3 mod 2, 4 mod 2, and 5 mod 2. So, if we run this, then we can see that 2 goes into 2 once with no remainders. That's why we get a 0. 2 goes into 3 once with 1 as a remainder. So 2 goes into 4 twice with no remainder. And 2 goes into 5 twice with 1 as a remainder. So we can see from this pattern that if you do a mod 2 on any number and there is no remainder, then that number is even. If you do a mod 2 on any number and the remainder is 1, then that number is odd. And that's a pretty common check that you'll use a lot throughout Python programming. Okay, so now let's look at the order of operations. Just like we would expect, we can also use parentheses to change the order of operations, just like with normal arithmetic. So for example, if we were to say, let's see, 3 times 2 plus 1, then with the normal order of operations, we would multiply 3 and 2, which would give us 6, and then we would add 1, which would give us 7. So if we run that, then we can see that we got 7 as our answer. But if I put a parentheses here around this 2 plus 1, then now with normal arithmetic, the way that this would work is that it should first add up these numbers in the parentheses, which should give us 3. And then 3 times 3 should give us 9. So now if we run this, then we can see that we got 9. So the order of operations does work correctly within Python like we would expect. Okay, so now let's look at another common operation that you'll see a lot, and that is incrementing a variable. So if I make a variable here called num, and I set this equal to 1, then what are some ways that we can increment that value by 1? Well, one way that we could do this is to say that num is equal to num plus 1, and if we print out that num, then we can see that it did increment it by 1 and now it's equal to 2. But incrementing values is such a common operation that there is a shorthand for this. So instead, we can just say num plus equals 1. So if we run that, then we can see that it still incremented that value up to 2. And you can use this syntax with the other operations as well. So instead, if we were to say num times equals 10 and ran this, then we can see that we got 10 because it took our original number and multiplied 1 by 10. Okay, so a couple more things here. We also have some built-in functions available to us to work with numbers. And one of these is ABS for absolute value. And basically, this will just remove the sign from any negative numbers. So if I took the absolute value of -3, and I'll just clean up a couple of lines there. Okay, so if we were to print out the absolute value of -3 and run that, then we can see down here that we just got the absolute value, which is 3. Now another built-in function that we have is round, and by default this will round our values to the nearest integer value. So if we said print the round of 3.75 and run that, then we can see that 3.75 rounded up to 4. And we can also pass a second argument into our round function that tells it how many digits that we want to round to. So if I put in a comma here and pass in a 1 as a second argument and now run this, then what we're saying is that we want to round to the first digit after the decimal. So we can see that that rounded to 3.8. Okay, so another common thing that you need to do when working with numbers is to use comparisons. Now we'll want to know if two values are equal, greater than, less than, and all of that. So to test this, we can use comparison operators. And I have some comments over here in my snippets with the comparison operators as well. And I'm just